In this video, we'll generate the trend line and trend line equations or polynomials of y equals x over 1 minus x, and also the Taylor-Maclaurin series sum expansion of this one y equals x over 1 minus x. So we first generate the data set using array formula of x divided by 1 minus x. And we'll chart this. We use scatter chart and generate the trend line polynomial to the degree 8. Show the equation as label and relocate it at the bottom. So here we have the trend line and the trend line polynomial of the y equals x over 1 minus x. Next, we generate the Taylor-Maclaurin series sum expansion of this. It is y equals x to the power k, where k is from 1 to infinity. And we'll try to reach infinity. That's the best infinity we can get. And the coefficient here is a is 1. So this is equal to array formula of k raised to the power 0. Now we can enter the Taylor-Maclaurin series sum expansion. So array formula series sum of the x values raised to the power starting from 0 or 1, incremented by 1, and the coefficient will be this range. And we show the polynomial, the trendline polynomial to the 8th degree. So here we have the polynomial, the trendline polynomial. We will calculate this regression coefficients using LINEST. These are the coefficients of the polynomial. To do that, we complete the 1 comma x matrix. So start with transpose, starting with the power transpose. Our degree is up to 8, so we can go up to 8 only. And we complete the 1 comma x matrix array formula of the x values raised to the power 0 to 8 and 1 to 8. And we can enter the LINEST data y and data x. Likewise, in the Taylor-Maclaurin series sum expansion, so LINEST data y and data x. Now we compare the coefficients. So the coefficient of x to the 0, they're different, but these are small numbers. So this is 0. The coefficient of x1 of x to the power 1 is 0.992, and the same as x squared. So they are the same, 0.992, 0.995. The coefficient of x cubed, 1.27, 1.16, they're the same. So these are 1.27, 1.16. That's x cubed and x to the 4th. X to the 5th and x to the 6th, that's so x to the 5th. So 1.07 negative and this one is positive. This is negative for x to the fifth, negative, negative, but x to the sixth, they're also negative. So x to the fifth and x to the sixth, they have the same coefficients, and x to the seventh and x to the eighth, they do have the same coefficients. This completes the use of array formula, Linus polynomial regression, in generating the trendline polynomial of y equals x over 1 minus x, and Taylor-Maclaurin series sum expansion using series sum for this y equals x over 1 minus x.